Why are radicals key to solving cubic equations? Imagine trying to find the exact value of a cube root or a square root without radicals. It would be like trying to solve a puzzle with missing pieces. Radicals are the pieces that help us complete the picture. When we work with cubic equations, which are equations where the highest power of the variable is 3, radicals become essential tools. They help us express solutions in a clear, exact way. Let's look at a general cubic equation. It looks like this: x cubed plus bx squared plus cx plus d equals 0. To make solving easier, we often simplify it by removing the squared term through a process called depressing the cubic. This transforms it into a simpler form, x cubed plus px plus q equals 0. Once in this form, we can use special methods to find the roots. One famous method is called Cardano's method. It involves setting the solution as a sum of two parts, u and v. To find u and v, we need to solve equations that involve taking cube roots of expressions. These expressions often contain square roots as well, which are also radicals. So, solving the depressed cubic involves extracting cube roots and square roots, making radicals unavoidable. Radicals allow us to write down exact solutions for cubic equations, not just approximate answers. Without radicals, we would only get close estimates, which are less precise. The formulas for roots involve radicals because the algebraic structure of cubic equations is more complex than quadratic equations, they requiring these roots to express solutions explicitly. Sometimes, especially when the cubic has 3 real roots, the formulas involve complex numbers inside the radicals. This is called the irreducible case. Even if the roots are real, the calculations might involve complex numbers, but radicals still play a key role. Trigonometric methods can sometimes help avoid complex numbers, but they still connect back to radicals because they relying on similar concepts. Understanding radicals is important because they are the building blocks for solving not just quadratic but cubic equations too. Knowing how to manipulate and simplify radicals makes solving these equations much easier. Recognizing that cube roots and square roots naturally appear in solutions helps you see how algebraic complexity is managed. In real-world situations, cubic equations appear in physics, engineering, and economics. Radicals help find exact solutions in these fields, making models more precise. Learning how radicals work in solving cubic equations builds a strong foundation for tackling more advanced algebraic problems. They are the key to unlocking the full potential of algebraic solutions and understanding the relationships between numbers and operations.